Welcome back, and it's the 20th of January, 5 a day, higher plus. Let's go with the first question. Okay, so what do we have? So a point 12.5 lies on a circle with centre 0, 0. Write down the coordinates of another 3 points. Cleverly worded question. Okay, first thing I think about, and again, this is a bit of experience coming through, 12.5 gives you a classic 12, 5, 13 triangle. So Pythagoras 12 squared plus 5 squared is 169. Square root of 169 is 13. And the reason that's helpful is because if I think about what I've got here, I've got a circle, and that circle has a, let's take the point 12.5, which is over here. Well, the radius must be 13 because this represents a triangle which is 5 up and 12 across. Now, if I know the radius is 13, that means I know the coordinates of all these points really easily on the axis. So I can actually write down a lot more than 3, but let's answer the question. So it could be 13, 0 or minus 13, 0. Or I could do up and down, so 0, 13 or 0, minus 13. There's lots of other choices. In fact, there's infinite other choices, but these are the easiest ones to do. First question done. Next question. Expand and simplify. Okay, so just to state the obvious, but we'll say it anyway, and it's less likely to make an error. X minus 3 cubed means multiply x minus 3 by itself 3 times. So let's do this the most consistent way whereby we're less likely to make an error. So multiply these first two first. So that's going to be x squared minus 6x plus 9. And I'm multiplying all of that by x minus 3. Now my technique is to multiply each of the values here by x, and then each of the values here by minus 3. So let's do that. Now the way I lay it out helps me do the next step. So x squared times x is x cubed. Minus 6x times x is minus 6x squared. 9 times x is 9x. And now let's do the minus 3. So minus 3 times x is minus 3x squared. Minus 6 times minus 3 is plus 18x. And minus 3 times 9 is minus 27. So then if I add all of these up, now you can see how I've written, so x cubed, x squared, x and 27 makes it very easy to add up. So I'm going to get x cubed minus 9x squared plus 27x minus 27. And that's my answer to that question. Not too bad, just being careful with the layout. Next question. Shown as a curve, y equals x plus 30, write down the course. Okay. So this question relies you understanding what your basic sine graph looks like before translating. Now the equivalent points to A and B is that point there and this point here. And if you know your sine graph, you'll know that point is 360, 0. And you'll know this point, I'll write it here, is 91. Now what does this mean? This means to translate left by 30 degrees. In other words, I'm going to take away 30 from both x coordinates. So that's going to give me that A is equal to, well, 90 minus 30 is 60, so 61. And B is equal to 360 minus 30, which is 330, 0. Next question done. Okay, what do we have? There are y sweets in a box. There are 20 sweets in the box. Y are lemon and the rest are orange. Florence takes out 2 sweets at random, so it's a conditional probability question. Find an expression. Okay, right, so it doesn't want me to solve anything. So find an expression in terms of y for the probability she takes 2 lemon sweets. Actually, this is not too bad, is it? So the probability of lemon, lemon. Now the first lemon, there are y lemon sweets to choose from and 20 sweets overall. The key to the question is the next lemon sweet, well, there's one less to choose from, but there's one less sweets overall as well. So if I multiply these things together, that's going to be y times y minus 1 over, well, 20 times 20 is 400. Take away another 20 is going to give me 380. Not as bad as it looks. Okay, next question. Shown is a frustum of a cone that has a perpendicular height of 40. Okay, calculate the surface area of the frustum. Oh God, this is a difficult question. All right, so first of all, what's going on? Well, we've got a cone, if you think about a normal cone, and then we chop a bit off the top. Now, what's made this slightly easier is the original cone was 40 centimetres and we're left with 20. In other words, we chop half off. So actually that makes all of these calculations slightly more straightforward. So there's definitely a slightly quicker way of doing this. You could use similar shapes, but let's just do it the slightly long way. So what I need to do is I need to work out the area of the curved surface of the large cone, the area of the curved surface of the removed cone, work out the difference between the two, and then add the circle on the top and the circle on the bottom. Now the thing to note first, because always do this before you sort of jump in, is the radius of the top bit is going to be half the radius of the bottom bit. So the radius of the bottom bit is 9 centimeters, and the radius of the top bit is 9 over 2. And again, that's because I can see 20 to 40 is scale factor of 2, so the little cone is half of the big cone. Let's just write down what we need. Now, in order to work out the surface area of a frustrum, you are going to need the curved surface area, and that is pi RL. So that's on the formula sheet if you do international maths, and you need to remember it if you don't. Then I need to work out the L, which is the diagonal side. Now there are two triangles going on here, one for the large cone and one for the small cone. So for the large cone, my height is 40 and my radius is 9, which means that this here is going to be the square root of 40 squared plus 9 squared, which is, get my calculator out, 41. Oh, that's good. Actually, the fact that's a nice round number makes me feel a little bit better that we're probably doing the right thing. And then the small cone is 20 high and 9 over 2. Now, again, area scale factors and length scale factors, I probably know what this number is going to be already, but get my calculator out. You do 20 squared plus 9 over 2 squared square rooted, and you're going to get 41 over 2. Which means the curved surface area of the large cone, so the cone before I took the bit away, is going to be pi RL, which is pi times 9 times L, which is 41, which is going to be 369 pi. And the curved surface area of the small cone is going to be pi RL as well, which is going to be pi times 9 over 2 times 41 over 2, which equals 369 over 4 pi. And again, perhaps unsurprising, because the scale factors are half, so therefore the area scale factor is going to be a quarter. That feels like that makes sense. Then we need the areas of the circles on the top and on the bottom. So the circle on the bottom is going to be pi times 9 squared, which is going to be 81 pi. And the circle on the top is going to be pi times 9 over 2 squared, which again, using the idea of scale factors, unsurprisingly, is 81 over 4 pi. Now let's be really careful. I need to add the first one. I need to take away the surface area of the cone that's been removed. I need to add the circle at the top, and I need to add the circle at the bottom. So I get my calculator out, so 369 minus 369 over 4 plus 81 over 4 gives me 378 pi, which if I put in my calculator is approximately 1190 centimeters cubed to 3 sig fig. That last question was a nasty last question, but actually not terrible, very doable. Just take it carefully and watch each step. As ever, like, subscribe, do leave a comment below if you have any questions, and I'll see you for tomorrow's video. Thanks all.